Hello and welcome to Tapas Pretzels, the adorsys podcast. Let's dive into today's episode.
Welcome to Tapas Pretzels Season 2. This time I'm going to be your moderator and host. I'm Tim. And I'm here with Dave, my co-host. And today our guest is actually our moderator and speaker, Inga. Because she's not only the moderator of Tapas Pretzels, she's also actually a software/data engineer. And Inga will gonna tell us today something about semantic data product. Am I right?
Yes, absolutely. So, long time no see, actually.
A few words about you, because people have seen you before, but probably haven't seen your biography so far. Like maybe run the audience a bit through where you came from, how did you end up in the podcast? Maybe there's also an interesting background story, and then we're gonna dive into the semantic data products.
Oh, so I guess I'm not sure if it's a long story actually, because it's actually quite short. I started at the adorsys not this year, but 2023, full-time job, and I wasn't in a project at that time. So Tim asked me, so, hey, can you do some slides for me? And I said, yeah, okay, why not? And so I ended up actually here in that podcast because you two, David and Tim, you said, okay, maybe we should do a podcast. And then I said, okay, I can do that too with you, or you invited me also. So yeah, therefore I'm here.
I must say that we are doing this with you, not you with us.
Yeah. Absolutely.
Okay.
But actually, we kind of insisted that you will be there, because otherwise it won't make sense.
Yeah, at least the best of three is going to talk.
Yeah.
So the Three Musketeers, or I don't know in English, is it the same?
Yeah.
Yeah, perfect. So thank you for the introduction. And I'm also, as Tim mentioned, I'm most of the time something like a full stack developer, but I'm also interested in data especially, and of course also AI, but I think because of AI you need data, and the data is the actual main part, I think, at that topic. And so therefore I'm also more interested in that. And I've also had my master thesis in kind of like that topic. So yeah, data is cool, actually.
Yeah, I agree with you on that. You know, we now tend to focus, or everybody is mainly focused on AI, but AI is not coming on their own. You know, it's not coming alone. AI is only the tip of the iceberg. To embrace or to put in place any AI software initiative or whatever, you need to rely on data, and not in any data. You need to rely in curated data, in quality data, because if data are low quality, are trash, you will. It's quite clear what are you going to get at the end of the process. Also, APIs are of few importance here. Why? Because data are spread all across the IT infrastructure, the IT solution of the company, and APIs is a way of centralizing that data access management. So and we can also mention other technologies. I would say now side technologies to AI, but are pretty much the same role of importance that AI. The main issue here is that AI is not only AI, and even data are not only data. You know, semantics are very important in data. You know, because it's not only about data; it's how, which is the meaning under those data. How are you going to interpret those data? Because a table could be a table, but a table could be the table you have at your dining room, the table tennis you have played to table tennis, your surf table. A table could be, you know, something that comes made of wood to do whatever you want to do. A table could be the ironing tool set you use to iron your shirts. So what about semantics? If you don't know,
I actually agree a lot of you, because you can also imagine for a software developer, if you go to a new project and there are something like also so some terms that you actually don't know, or if you have like a relational database, so you see those tables and you think, okay, what does it mean? And then you look into the code and they have some different terms, but they actually mean the same. So it's also interesting for a developer to get to know what does it actually mean, what I'm working with. And you have to imagine if you have a lot of projects, not, of course, you are in one project, but of course, a company has a lot of different projects. And if you think about, you have a lot of people, you have a lot of dashboards, and to integrate all that in one concept, it's really complicated because you have a lot of data. And semantics could also help to, I would say, maybe also standardize to get a single source of truth out of your data. And that's also really important for the AI because we can actually rely on the data because we know where the data comes from and is it actually safe enough, especially in working spaces for tax or for personal data or for banking information, where you have to have a lot of security. So I think,
And now put yourself into the shoes of the business departments or the IT security or governance departments, because like when you say we know where the data comes from, like I think business knows it way better because they know the actual process before actually the data appears or will be created during the process. That can be the digital or the analog process. But business people, they have a clear business view, business process, business terminology. It's an industry expertise they have. And they now putting this into like requirements. What kind of requirements? So like, hey, IT department, please do something here. And they're giving this to the developers, and they're gonna implement something. And the business has to rely on the, okay, I have to trust that these developers actually understand finance math itself, or like the terminology, or how things relate to each other. Like what could be thresholds? So I'm like, it's as a business, how can you have an understanding? You give it to someone, this disappears in a black box, and then there's an output, a dashboard. And there is also like, I think there's both worlds are not that well connected to each other. I think there we need some more connection.
Yeah, absolutely. So I would say there are concepts that could help to get the same understanding how data actually works. So, for example, you have something like, okay, relational database, so nobody actually knows what to do with it. And you also have a guy or a woman who is not in the technical aspect of the implementation, but so you need something like a glue, and that could be also, first of all, to do with an ontology. So that's the first term I want to spit in here. An ontology, that's also depending on the semantics or is a word from the semantics, where it's easy to define what the world actually is. So you can imagine like a graph, I would say. It's like a graph structure. For example, you have land. You also have I don't know, the country code maybe also. You have a city, and those data is actually in the relational database. We know that a city is inside of a land, but the data doesn't. So we have to put this information that we know or the business side know into the data. And this could also happen with, as I said, an ontology. So there you have two terms, or you have like a subject and an object, and you put a relation between those. So you have, for example, you say a land has a city. So you get to to do the information, or you put the information into your data. And that's really, really helpful if you work with two people. So you have someone from the business side, and you also have someone from the technical aspect. If you to create the ontology or your business ontology, for example,
context to the data.
Yeah, right. Exactly. So that could also be helpful, but I think it's not the only thing that you also need. So you have, first of all, your ontology, but what to do with the actual data. So of course you have to get a ETL process, or you have to actually merge your data sets within. So I'm not sure, I can maybe, or you also have to, as I said, the personal data, you have to secure it. So who is responsible for the data? So give me 1 second. I can show you.
That's
Yeah,
correct.
absolutely. Governance. In the ontology, you can't really describe it in that way, who is actually or has the permission to see the data. So you need a second concept. And that could be, you can say it to me.
No. Sorry, I wouldn't want to interrupt you. Sorry.
No, you can speak, Tim.
Yeah, well, I was just saying it helps, like if you represent the data in this kind of knowledge or graph structure, it helps because like people see it, and actually you can really, as I said, like the country code or the city, or if you take this further into like people of like maybe the private phone number or the private address or the company address, the official address. Some of this data, those attributes or connections, are have more, as I said, like security wise, have other confidentiality. Like this is something which you want to flag as not shared with everybody, just only for HR purposes or whatever. And so you can actually also put this into in the graph structure where people understand it pretty well, and you can really label it, attribute it, or in all kinds of possible ways, like make this transparent for all kind of use cases where you have this built together. Sorry, I didn't want to interrupt you, but it just triggered in my head like the endless amount of possibilities in if you put this graph annotation concepts in place.
Yes, absolutely. No, you don't or didn't interrupt me. I think it was also really helpful. Yeah, David, what do you think about the concept with graphs or something like a knowledge graph? I think.
Yeah, I
agree.
I agree, Tim. You know, I think that data by nature are complex. So if we are able to abstract from that complexity and depict the complexity, even simplifying that complexity in a way that is easily understandable, but people who are going to manage the information, everything is great. You know, graphs are very simple if for low complexity data. Graphs are very simple because you can see the connection between different concepts. The problem is what happens with data that are really, really complex. You have to oversimplify things to have a clear representation, or use a 3D representation of the relationships, which in 3D sometimes it's very difficult to see, you know, in 3 dimensions the relation between data. But anything you use to simplify and to show which is underlying all your data layer, it's great.
Yes, and I also thought about, of course you have like your ontology, but I mean, one domain doesn't actually know what kind of data they have, and we want to get to the state of where we have a domain that is responsible for their data. And there's a concept called also data mesh that could help to make it more, I would say, more structured and more like into simpler task for everybody, because right now you have like a lot of separated data or separated data teams who are only responsible for the data, And that's not so good because, of course, some domains want, hey, can you get the data for me? And they also have to transform it. And if we want to integrate now ontologies, they have a lot of more to do with the business or with the ontologies or with the domains. And that could also, could be really, really overwhelming. So the concept is now, okay, every domain should actually do their data on their own. And what could also help is to get the new buzzword that is called data products. And I'm not sure if you ever heard of data products. I'm pretty sure that you've heard of data products, but not everybody. So a data product for, I would say, like a software developer, it's something like you have a data model, but a data model with, with more features. For example, you get to know what is the data quality of your data product, or also you can say, hey, who is responsible for the data, who can actually access the data, and so not one specific or one or a lot of more data teams are responsible for the data, but the domain itself is responsible for the data products. And if you combine those two concepts with data products and the semantics, where you can actually get to know what the data means, also with a relationship to other domains, therefore you have something like a semantic layer, or moreover a knowledge graph. And with this knowledge graph you can do a lot, because you know what the data means, and you get to know where the data actually relies, or which data do you want to use. So, because sometimes it's also like companies don't know actually what data they have. So this could be a good concept, and therefore I also have a good slide for it, how we actually can realize this idea of data product, or something like a semantic data product. As you can see on the slide, there are three kind of things that you can continuously do, or simultaneously do. First of all, as I said, you can create your business ontologies with a business expert and an ontology engineer, for example. Okay, where to put this business ontologies? The business ontologies go into the linked data platform. So the linked data platform is something like, I would say, a marketplace where you actually can find all those data products, or which kind of data do you have, what kind of ontologies also you have, and to maintain all that, and also to communicate between the actual data product managers and the data engineers. This is the semantic layer team who is responsible for that. And of course, you have a data product manager, because as I said, semantics and a data product can be also without semantics, but as we know, that doesn't make any sense right now. So, but you can also separate it in that case. So you have a data product manager who is maintaining this data product, also to create the data products, developers, data analysts, and data product consumer, and so on, as you can see here. And you have also your data engineers who actually transform your operational data stores, or map your data through your ontologies, but also map your data sets in between. So you have also maybe two steps that you have to do. So you have to map your data with your data, so that you get the single source of truth, but you also have to map your data to the ontology. And if you map those all together, then you have like a consistent thinking, or a consistent, I would say, data set, for example. So, I don't know, an ID is an ID, or a city is a city like nothing else, I would say. Of course, there are a lot of different kind of terms depending on how the business is implemented. And therefore, if you have the ontologies and linked it to the linked data platform, you know that, and you can also look what kind of data does it actually have in your data product or in your data sets, for example. So
For me to sum it up, because it's a quite complex slide.
yeah, absolutely.
So just like maybe going by use case. So if let's take a bigger use case where it's like, okay, you do merging and acquisition. So one company buys another company. If company A that buys B has defined an ontology of, I don't know, let's say we stay in the finance field, like say, okay, this is what does an account mean for us? Like this is an IBAN, this is the account holder, these are people that have permission to the account and so on. And if I have this ontology basically, and I can use this linked data platform and the mapper of the images, I could actually use my existing operation data stores from company A, but also could take the same ontology and let from company B adding their existing databases to it, so that still everyone in the company A understands what account means because they have the common ontology. And if B joins into the company, there's not much of transition problems, project needed, because they can stay in the same language. This will do the automatic mapping for them. And people will automatically, as long as they work against the ontology, not the actual database itself, they can quite easily integrate or get access to the new data. Am I right?
Yes, absolutely. I would say it also helps for, I mean, if you have something like a meta ontology, okay, I don't need to create in my business ontology this term, or you have to create this property, and it makes it more faster, I would say. And also the same language also helps in that case. So yeah, I would say that.
Okay, so also
I would agree with you.
Yeah, okay, so if company B probably has also some more features or attributes to whatever their account means for them, they could go to the first ontology, the system ontology, adding their concepts to it by aligning on the business sides. And then like basically they could feed in the existing information and or like add this information back to the other systems in A. So basically then build it and aggregate out of it. Best of all worlds. Am I right? Or misunderstood something?
Yeah, I agree. I think you're right, Tim. But even one another important topic here, which is traditionally there is a gap between IT people and business people, and semantics and ontology allows to break that gap and fill it. Because why? Because the same concept for IT people is different, but for business people it has different meaning. In a company, think what happens in different companies. So that's why semantic is so important, and structure like that in the slide is really key. I think it's the Rosetta Stone for data in the next short term.
And if you see the right side, there's the data product marketplace. So basically what we have spoken before, like if you have that ontology and you can actually attribute to these information if it's a private or non-private thing, and it's like, hey, I publish a product that takes information from the ontology, it could automatically the process of building a data contract so that you consume the product will be actually steered automatically by the information that this product contains, because all these required information are probably in your ontology. And if the linked data platform team could say, hey, there's like a schema enforcement basically in place, where say, hey, every node in my graph needs to have the following attributes. So basically, to publish it, you need to fill how classified is the data or not. And then basically the respective data product management platform could then say like, hey, I'm going to steer this data contract request into the right people in the governance audience or in the respective groups or enterprise processes. And then this makes also data sharing more reliable, and you can be sure as a consumer that you can do with the data what you plan to do. Oh.
Exactly. And you also have your data product where you can actually, or you have your data product and also maybe also your data model, and the main focus or the advantage out of it within a linked data platform, you can actually jump to the ontology or to your linked data platform and see how the connections are between those data products also, and also the connection between ontologies and so on. So it's not only that you have your data product, but you can also show the metadata out of the data product. So that also helps a lot of for the developers in that case, if they want to consume the actual data product to use it in general.
Interesting. And one final last observation, but we cannot get without it, like AI. So all the large language models are trained on knowledge graphs. So this can be then also a foundation for your own knowledge graph, or at least use this as an input for your RAG, or building basically semantic RAG concepts. Because if you have existing ontologies, can combine this with your actual data sources and some LLMs, privately or publicly, this will gonna lead to much better accurate results.
Okay, highlighting how important semantics are in when you are dealing with data, no matter the nature of the data or what you are doing with your data. Semantics are the light of in the data ocean. So everybody is focused in AI on or data, but what happens with semantics? They really, if you want to get gold from data, you will need semantics for sure, because semantics is the language or the meta language you use to interpret what data are for. Without that language, it's impossible to analyze data. If you want to make a very in-depth analysis of your data to extract very valuable conclusions, you need to put semantics somewhere in your life cycle.
Yeah. And I couldn't agree more. Thank you, Inga, for this presentation and sharing these insights with you. And I would close it with the words that David said in the beginning, like everyone talks about AI, and the tip of the iceberg, like putting some new frontends on ChatGPT, but it's more important actually the groundwork, that we have data literacy in place, that we have the data quality in place. And I think all that you have showed with us, Inga, today is actually where people need to understand this is the foundation if you want to do data management and get to the AI era itself. Like this is basically the recommendation to follow. And thanks, Inga, again for being here. And thanks, Inga, that you be our moderator and closing session. Because I'm really bad in this. And looking forward to next episode where you moderator and for all of them the time and the closing and the opening. And thank you.
So I can do the actual closing. So thank you that you've watched our podcast. And if you want to follow us on LinkedIn and YouTube, then you can do it on the adorsys channel. So, and of course you can reach out to us, to David, Tim, and me also. So we will see us next time, right?
Thank you, Inga.
Bye-bye.
Bye.